The $15 billion project that might unravel. Imagine you were promised a super-fast train that would cut an 8-hour trip down to 2. Now imagine that the train never runs. Not because of a missing bolt, but because giant machines needed to dig the tunnels are stuck in another country. And, the bill just keeps growing. That's the short, strange story of India's Mumbai-Ahmedabad high-speed rail, a $15 billion dream that looked unstoppable, until supply chains, geopolitics, and money problems turned it into an international headache. Let's start with the numbers, because honestly, numbers are hard to ignore. The project was backed by tens of billions in foreign money. Japan provided the big loan, and at one point India had to rely on specialized tunnel boring machines ordered from abroad. Those machines aren't small, they're longer than a football field and cost hundreds of millions. When they didn't arrive on time, the delay wasn't just an inconvenience. It pushed deadlines back, pushed interest and costs up, and turned a local construction problem into a diplomatic standoff. Here's the punch. This isn't only about trains. It's about how modern megaprojects depend on a fragile web of banks, engineers, visas, factories, and geopolitics. A single failure in that web, one delayed payment, one refused visa, one seized shipment, can ripple outward, and suddenly a flagship national project becomes a headline about debt and blame. In this video, we'll walk through how that happened, the promise, the international money and machines, the bureaucratic knots that tied the whole thing in place, and why India and China ended up accusing each other. Next, we'll look at why this rail line mattered in the first place, the real economic and human changes it was supposed to bring. To understand why this rail line was such a big deal, let's look at the two cities it was supposed to connect, Mumbai and Ahmedabad. Mumbai isn't just any city. It's India's financial heartbeat. Picture the city packed with millions of people, buzzing streets, and the constant hum of industry. In 2022, Mumbai's GDP was around $310 billion, which is roughly 9% of India's entire economy. Its per capita GDP is over 5 times the national average, showing just how concentrated wealth and business activity are there. On the other side is Ahmedabad, Gujarat's largest city and a powerhouse for the cotton and textile industry. It's like the industrial engine of Western India, with a network of ports, rivers, and roads that make it perfect for moving goods. Together, Mumbai and Ahmedabad form a corridor where people travel constantly for business, trade, and tourism. Now imagine the journey today. Traveling between the two cities by ordinary train takes about 8 hours. The high-speed rail promised to slash that to just 2 hours, like turning a long road trip from San Francisco to Los Angeles into a quick flight. That's not just a convenience, it's a potential boost for commerce, tourism, and manufacturing. Shorter travel means faster business deals, quicker shipments, and more people moving between jobs and opportunities. So the stakes were huge. This wasn't a small subway project. It was a national-scale investment meant to modernize one of India's busiest regions. And that's why any delay or obstacle, whether technical, financial, or political, would ripple far beyond the construction site. Next, we'll dive into how India funded this ambitious project and brought in foreign technology, a mix that would later become a critical point of tension. Building a high-speed rail isn't just about tracks and trains, it's about money and, honestly, the right technology. India needed both in huge quantities. To kickstart the Mumbai-Ahmedabad project, it borrowed $14.6 billion from Japanese lenders. That's a massive loan, enough to cover most of the $15 billion project, and it came with expectations, deadlines, technical standards, and repayment schedules. But loans are only part of the story. Then there was the technology. The trains themselves were based on Japan's Shinkansen, the famous bullet trains known for speed, safety, and precision. But the tunnels, especially one 21-kilometer stretch including 7 kilometers under the sea, required something far more specialized: massive tunnel boring machines. India didn't manufacture these at home, so they looked abroad for the best options. After discussions, German companies recommended a type called a horseshoe shield machine, which could dig tunnels efficiently, stabilize the ground, and handle complex geology. Something ordinary excavators couldn't do. Here's the twist. Although the machines were German-designed, they were manufactured in a factory in Guangzhou, China. That meant India's ambitious plan now depended on equipment built in a country with which it had tense political relations. On paper, it made sense. The best design, an experienced manufacturer, and advanced machinery. In reality, it planted the seeds for a future bottleneck that no loan or engineering plan could fix alone. Next, we'll dive into the story of these shield machines, the colossal tunneling tools that became the center of the project's biggest crisis. To understand why the project stalled, we need to look at the star of the construction, the shield machines. These aren't your everyday excavators. Imagine a machine over 80 meters long, longer than a football field, designed to cut through rock and soil while simultaneously lining the tunnel with concrete, removing debris, and keeping the surface above from collapsing. That's a horseshoe shield machine. In contrast, a normal excavator is like a mechanical shovel. It digs, lifts, and dumps, but can't form a safe tunnel by itself. India ordered 3 of these machines from Germany, spending over $330 million. They were supposed to be delivered and assembled in time to start digging the tunnels under Mumbai. But here's the catch. Although designed in Germany, the machines were manufactured in China. In October 2024, China suddenly seized the shipment. The machines, critical to the project, were stuck in a bonded warehouse, unable to reach India. Think about that for a second. The project wasn't delayed by weather, labor strikes, or design flaws. It was delayed because 3 machines the size of a building were literally frozen in another country. Without them, excavation slowed to a crawl. The dream of reducing travel time from 8 hours to 2 became a distant promise, and the stakes for India's timeline, debt, and credibility grew higher every day. Next, we'll explore the backstory, why India struggled to get these machines, the visa and payment disputes, and how administrative choices turned an engineering problem into an international standoff. The problem with the shield machines didn't start in 2024, it goes back to 2020. India had ambitious plans for several large infrastructure projects, and it wanted to buy advanced Chinese-made shield machines to support them. Initially, China agreed, even offering technical support. But soon, cracks appeared in the cooperation. India began refusing visas for Chinese engineers, preventing them from entering the country to assemble and maintain the machines. At the same time, final payments were delayed or withheld. Why? Well, partly, India was under serious financial pressure. In 2022, its fiscal deficit reached 6.9% of GDP, and total debt hit more than 75% of GDP. Foreign exchange reserves were shrinking fast, making it difficult to pay for expensive machinery imported from abroad. Some experts also suggest that India deliberately delayed payments to study the machines themselves, hoping to reverse engineer the technology to develop its own shield machine industry. But reality hit hard. Indian engineers, without the support of Chinese technicians, couldn't assemble or operate the machines properly. The lack of cooperation turned a technical challenge into a political and logistical deadlock. As a result, the first batch of German-designed machines, already stranded in China, couldn't be deployed, and construction progress slowed dramatically. Next, we'll look at the consequences, how these delays affected the project timeline, India's debt, and the political fallout. The ripple effects of the shield machine saga have been massive. Construction at Mumbai's high-speed railway station, for example, has only partially progressed. While 142,000 cubic meters of the foundation pit have been excavated, the total needed is 187,000 cubic meters. Without the 3 massive machines, completing the tunnels is impossible, pushing the project's completion from 2024 all the way to 2030. This delay doesn't just cost time, it costs money. The initial $14.6 billion debt has already grown to roughly $18 billion due to interest and financial pressures, adding a huge burden to India's budget. Meanwhile, public frustration is mounting. Citizens see delays, rising costs, and hear about foreign equipment being seized, creating anger and confusion. Politically, the tension has found a target. To deflect criticism, the Indian government has blamed China, pointing to the border conflict in 2020 and the seizure of German-designed machines built in China. Media reports have reinforced this narrative, often implying that China deliberately obstructed India's development. Meanwhile, frustration has also been expressed toward Germany for supplying machines manufactured abroad rather than locally. In short, what started as a technical and logistical challenge has grown into a multi-layered crisis, combining finance, politics, diplomacy, and national pride. Next, we'll analyze responsibility and explore what alternatives India might have had to prevent this chain reaction. So, who's really responsible for the delays? The answer isn't simple. From one perspective, China acted within its rights. India hadn't completed payments, and shipments of valuable high-tech machines can be legally held. From another angle, India's fiscal problems and refusal to issue visas to Chinese engineers created a bottleneck that made it impossible to assemble and operate the machines. Germany, the designer, provided guidance but didn't control the manufacturing or export approvals, leaving another weak link. Could India have done things differently? Several alternatives were possible. They could have diversified suppliers early on, leasing machines or buying from countries with fewer diplomatic risks. They could have allowed Chinese engineers to work under strict oversight rather than denying visas. Phased construction or modular projects might have reduced upfront capital requirements and dependency on single shipments. Each option had trade-offs. Faster access might cost more, political trust could be strained, or the timeline could extend in different ways. This analysis shows a clear lesson. Mega projects don't fail solely because of engineering challenges. They fail when finance, supply chains, diplomacy, and domestic policy intersect in fragile ways. Every delay in one area compounds risks in the others, creating a chain reaction that turns a national dream into a high-stakes puzzle. Next, we'll wrap everything up with a conclusion, reflecting on lessons learned and the larger implications for India and similar projects worldwide. The Mumbai-Ahmedabad high-speed rail project tells a story bigger than trains and tunnels. It's about how modern megaprojects depend on a fragile mix of money, technology, international cooperation, and political trust. A single delay, like 3 enormous shield machines stuck in China, can ripple across years, push billions of dollars in debt, and turn a symbol of progress into a diplomatic standoff. The project also shows the high stakes of global supply chains. Even with German engineering, Japanese loans, and Indian ambition, dependence on a foreign manufacturer in a tense geopolitical environment created risks that were underestimated. For India, the lesson is clear. Managing big infrastructure projects requires not just engineering skill, but strategic foresight in finance, international partnerships, and domestic capability. So, what's next? Will India find a way to complete the rail line by 2030, or will international tensions continue to stall progress? And could other countries learn from this story before launching their own mega projects? If you found this story insightful and want to follow future developments on this project and other global infrastructure challenges, make sure to subscribe to the channel and turn on notifications. And tell us in the comments, do you think India or China holds more responsibility for the delays? Your opinion could be part of the discussion as this story continues to unfold.